Let's see the center of mass, second part. So we already discussed about center of mass. Okay, what is meant by center of mass? The mass which is supposed to be concentrated at the center, and that should be exhibits translatory motion. There is no need to be total mass to be at the center. Okay, it might be at any point, but it should be in straight line, translatory motion. Okay, right. Now we are going to discuss about position of center of mass. So what is the position of center of mass? How can we find the position? For example, let's take x-axis, y-axis. So if an object particles are at different positions. So this position R1, R2, R3, R4 and R5, these are the positions of the object. R is the position. Okay. So from the center it is at a distance of R1, and this is at a distance of R2, and this is R3, R4, R5. Okay. So these are going to be measured. Each particle have mass m1, m2, m3, m4 and as well as m5. So how to find this position of center of mass? Already we know that to find the along x-axis, what is the center of mass? m1 x1 plus m2 x2 plus and so on by m1 plus m2 plus m3 and so on. So this will simply written as summation I equal to 1 to n mi xi by total mass capital N. So similarly this also will be written as RCM equal to m1 r1 plus m2 r2 plus and so on by total mass capital M. Okay, so simply this will be written as summation I equal to 1 to n mi ri by capital M. Okay, so this is for position of center of mass. Okay, clear? Understand? So here R1 will may be along x-axis. So this particle have 3 dimensions, might have 3 dimensions. If that particle is along x-axis, then x1 I cap plus y1 j cap plus z1 k cap. For R2, x2 I cap plus y2 j cap plus z2 k cap. So for if it is an nth particle, x nth I cap plus yn j cap plus zn k cap. Like this we have to frame the vectors. Okay, so this is about position of vector. So this is the formula for position vector of center of mass. Okay, clear? Right. Next see that motion of center of mass. Motion of center of mass. Okay, so what is the motion of center of mass? Now the particles are in motion. Now in the system we are considering, in that particles are there. If the system moves, then the particles also in motion, right? So here about to find the velocity. So already we know that RCM equal to m1 r1 plus m2 r2 plus and so on by let's consider two particles by total mass m. Okay, m1 plus m2. Okay, so now if we will take m this side, it's m RCM equal to m1 r1 plus m2 r2 plus and so on. Here I have considered for only two particles, so let it. Now differentiate it. So anyway, if you are differentiating also, mass remains constant only, no? There is only changing distance. So mass into dRCM by dt equal to m1 dr1 by dt plus m2 dr2 by dt plus and so on. Okay, so here mass constant m, drcm dy dt of position, that means displacement, change in displacement with respect to the time or rate of change of displacement is called as velocity of center of mass equal to m1 v1 plus m2 v2 plus and so on. Okay, got it? M vcm equal to m1 v1 plus m2 v2. Got it? No? So this is about simple mass. Now I want to find only velocity. So that m1 v1 plus m2 v2 plus and so on by total mass capital M. So here total mass means m1 plus m2 for two particles. Multiple particles means total mass, the total mass particles. Okay, so this simply will be written as summation I equal to 1 to n mi vi by capital M. Okay, this is for velocity of center of mass. Summation I equal to 1 to n mi vi by m, where m is the total mass, m is the each particle mass, and v is the velocity of each particle. Okay, so that we can find the total center of mass. Got it? Next. So now we will see about still let it complete. MCM equal to m1 v1 plus m2 v2 by total mass m. Okay, now if the two particles, here I consider two particles, right? So let me write as m1 plus m2. So if two particles are moving same direction, so then velocity of center of mass will be m1 v1 plus m1 v1 m1 v1 plus m2 v2 by m1 plus m2, as both are in same direction. Same direction. If it is moving in opposite direction, then mvcm equal to m1 v1 minus m2 v2 by m1 plus m2. Direction is changes, opposite direction. If both are moving in perpendicular direction, then vcm equal to root over m1 v1 square plus m2 v2 square by m1 plus m2. This is for perpendicular direction. Okay, so these are the formulas regarding velocity. Then what about for momentum? Momentum. What is the formula for momentum? Momentum is nothing but mv. So if this total mass I consider as m, and if I'll take that side, then that will be m vcm equal to m1 v1 plus m2 v2, right? So mv is nothing but momentum, so it's nothing but pcm, momentum of center of mass, equal to p1 plus p2 plus and so on, right? So simply this will be written as summation I equal to 1 to n pi. Okay, this is for momentum of center of mass. Got it? Next. Next, what about acceleration? What is the velocity of center of mass? mvcm equal to m1 v1 plus m2 v2. Now differentiate the velocity vcm. So now mass is same, then dvcm by dt equal to m1 dv1 by dt plus m2 dv2 by dt. So then m into dvcm by dt is nothing but change in velocity. Change in velocity is nothing but acceleration. So m1 a1 plus m2 a2. From this, what is the ACM? ACM equal to m1 a1 plus m2 a2 by total mass, this capital M. Okay, so this simply will be written as summation I equal to 1 to n mi ai by m. Okay, so this is for acceleration. Okay, got it? Understand? So this is about simple position, velocity and acceleration for center of mass. Okay, right. Now we will see that. Now we'll see the question now. That is I already framed for you. We'll see that question. Yeah. So there are two cages, three cages. Masses have velocities v1. v1 is 2 I cap plus 3 j cap meters per second, and v2 is 4 I cap minus 6 j cap meters per second. Find a velocity of center of mass. We need to find the velocity of center of mass. and the total momentum of center of mass, and the velocity of center of mass. Okay, we'll see that later. Now let's complete this VCM and PCM. So what is the velocity of center of mass? What is the formula? m1 v1 plus m2 v2 plus, no need to write, as they are about as 2 only. So m1 v1 plus m2 v2 by m1 plus m2. So velocity at center of mass equal to m1 is how much? 3 kg. v1 is 2 I cap plus 3j cap plus m2 3 again. v2 is 4 I cap minus 6j cap by m1 plus m2. It's 3 plus 3. So it is 3 to 6 I cap plus 9j cap plus 12 I cap minus 18j cap by 6. Okay, then velocity at center of mass equal to 6 I cap plus 12 j cap, which is 18 I cap, 9 I cap minus 8 j cap, it's a minus 9 j cap by 6. So velocity at center of mass equal to 6 ones, you can write it separately. That means 18 by 6 I cap minus 9 by 6 j cap. So velocity at center of mass equal to 6 ones, 6 threes. So 3 I cap minus 3 twos, 3 threes. That means 3 by 2. 3 by 2 means it is 1.5 j cap meters per second. So this is the velocity at center of mass. Okay. Still, what they ask you to find? They asked us to find. What they asked us to find? Momentum. How to find the momentum? As you already got velocity at center of mass. Now we are about to find the momentum. Okay, we'll find now. So I want to find the PCM. So what is the PCM? PCM equal to m VCM. As we know VCM here, so I am going to replace it. So PCM equal to mass, total mass. Total mass is how much? 3 plus 3, 6 into VCM. VCM is 3 I cap minus 1.5 j cap. So it is 18 I cap minus 9 j cap meters per kg meters per second or Newton second. Okay, this is the for momentum. Okay, now still what we need to find? Still we need to find for velocity. Okay, here I have velocity. Now I'll use that again. Listen. Now they ask you to find the velocity of center of mass after 5 seconds. Now time has given 5 seconds. After application of constant force, so force also there, 24 I cap newtons. Okay, 24 along I cap only it was there. And the position also we need to find. Position we are denoted with R, let it be. This also for 5 seconds only. Okay, now to find, they have given force and time. They ask you to find the velocity after 5 seconds. Then what about this velocity? This is the velocity at initially. So this velocity is initial velocity. Now to find this, initial velocity knows, force knows, and mass also knows. What is the total mass? 6 kg. Now what I need to find? Velocity. To find the velocity I need of acceleration, as v equal to u plus at. From this I need to find acceleration. So what is the acceleration here? F equal to m a c. Cm. Cm center of mass. F is how much? 24. Mass is how much? 6. Acceleration don't know. 6 ones are 6 fours. So ACM equal to 4 I cap meter per second square. Okay, it's along I axis, I cap x axis, 4 meter per second square. Now substitute v equal to u plus vt. What is the initial velocity? This is the one, that is 3 I cap minus 1.5 j cap plus acceleration is 4 I cap into time. Time is for 5 seconds. So v equal to 3 I cap minus 1.5 j cap plus 20 I cap. Then v equal to 20 plus 3, 23 I cap minus 1.5 j cap meters per second. So this is the velocity at when velocity after 5 seconds. Okay, this is the velocity. Now what they ask still? Position. To find the position with an acceleration, what is the formula? S equal to ut plus half a t square. Okay, now we'll see that acceleration is 4. So now r equal to vt, I mean v center of mass t plus half a center of mass into time t square. So now r equal to r vcm. Vcm is 3 I cap minus 1.5 j cap into t. Time is for 5 seconds. Okay, plus half into acceleration is 4 I cap into t square. T is nothing but 5 square. So it is 3 I cap minus 1.5 j cap. So multiply now. So we'll multiply now. So 5 3 is 15 I cap minus 5 1 is 5, 5 5 is 25, it is 7.5 j cap plus 2 ones 2 2. So 2 I cap into 25, 25 to 50. So 50 I cap. So it is 50 plus 15. So 65 I cap minus 7.5 j cap. So this is the position. That means this can be written in terms of coordinates is x comma y will be equal to 65 along x-axis minus 7.5 meters along y-axis. Okay, clear? Understand? Right. And let's see the another one. Now there is x-axis and y-axis. It is the application. Okay. So now here let's consider there is one boat. Let's consider boat. This is the total mass where the total mass is to be concentrated. Now there is a person. A person is standing here. Let's consider that mass is small m. Now where the total mass is concentrated? Total mass is concentrated at the center of mass. Okay, right. Let's consider the distance for total center of mass is x1 and the distance from the shore, from the surface to the mass of the man. Okay, mass of the man is, let's consider x2 and the distance to the center of mass is xcm. Okay, now this person moves from there to here. When the person moves, the boat is about to move like this. Okay, and the boat moves, center of mass of this remains same, it is not goes anywhere. Then what? The total mass of boat is same. Then what about the person? Person comes to this end. Okay, small m. Got it? Now from here to here it has moved. Which has moved? Boat. How much distance? S distance moved. Let's consider the total boat length is L. Boat length is small l. Okay, right. Then right now see that initially small mass is x2. Now the small mass distance is x2 dash. Okay, then what about capital M? Capital M is placed at this point. This is at a distance of x1 dash. Initially it is x1, now it's an x1 dash. Okay, got it? Next, here center of mass is there. Then here where is at this point center of mass. So center of mass is not changing. It is at same position. Okay, center of mass is at same position. It is not changing. So that means from here to this point distance is x center of mass. Okay, got it? So now initially distance is x1 and other distance is x2. Okay, and the total mass when it is x1 distance, the total mass is capital M. When it is x2 distance, the total mass is small m. Okay, now center of mass is same. It is about to travel distance of length L. So now what about x1 dash? What about x1 dash? X1 dash equal to total distance from here to here. This total distance. This total distance will be equal to where? To the center. Okay, how much distance it moved? It moved distance of s distance. Okay, so x distance, this distance and this one. That means x1 plus L. So x1 dash equal to x1 plus L. X1 dash, this total will be equal to x1 plus L, this distance, that is this one. Okay, right. Now what about x2 dash? X2 dash, this is x2 dash, right? X2 dash plus this total length, x2 dash plus total length of the boat equal to x2 dash plus total length of the boat equal to x2 plus s. x2 plus s. This plus this will be equal to this total. Okay, that's what it is. So from this x2 dash equal to x2 plus s minus L. Okay, so now from these two, according to the center of mass, xcm equal to m1 x1 plus m2 x2 by m1 plus m2. Now according to this x1 dash and x2 dash, xcm will be equal to m1 x1 dash plus m2 x2 dash by m1 plus m2. When it will be? When it after a person moves from one end to other end of the boat. So now xcm equal to m1 m1 is what here? Capital M into x1 dash. X1 dash is x1 plus L plus m2. M2 is small m into x2 dash. This is the one. x2 plus s minus L. Okay, by capital M plus small m. So according to this, this is also will written as xcm equal to capital M x1 plus small m x2 by capital M plus small m. Now after I am going to equate both the center of masses. Why? The center of mass is not changed, it remains same. Okay, so I am going to equate both. So after equating, I will arrange it. So now I am equating both. So after equating capital M x1 plus small m x2 by capital M plus small m equal to capital M x1 multiplying m into x1 plus capital M L plus small m x2 plus m s minus m L by capital M plus small m. Capital M plus small m gets cancelled. Okay, so here mx1 gets cancelled, mx2 gets cancelled, then 0 equal to capital M L plus ms minus m L. So So you can take ml this way. Ml equal to ml plus ms minus ml. So from this, somewhere something as m into l plus x2 s minus m1 l. Sorry, this is x1 plus s. Change it. It's an x1 plus s distance. Okay. So it is s m1 m s. Okay. So now ml equal to capital M plus small m into s. So from this, s equal to what is the s here? So s equal to small m l by capital M plus small m. So this is the distance with which it traveled when a person moves from one end to this end. This has moved a distance, s distance, that is this one, ml by m plus m. Okay, this is the distance. Now I am going to differentiate this. I will tell you. So what is that? S equal to ml by capital M plus small m. Okay. Now when the person is moving with velocity, so that boat is moving in this direction, velocity of the boat. Okay. So in this direction, now I am going to find the what velocity they are both are moving, so that center of mass remains same. Now displacement ds. So ds means I am going to differentiate this. ds by dt equal to m by capital M plus small m into length is going to change, no? So dl by dt. Okay, right. So now a person is moving in the boat with a velocity vm. From where to where he is coming? From one end of the boat to other end of the boat. So velocity of the man is dl by dt. And how much distance boat will move? Boat will move from here to here, a distance of s. So velocity of the boat is ds by dt. So from this ds by dt is nothing but velocity of the boat. Velocity of the boat equal to m by capital M plus small m into dl by dt is nothing but vm. Okay. So velocity of the boat equal to mass of the man by total mass of the boat plus mass of the man into velocity of the man. Okay.